Hi, in this video we want to answer the question, what is a linear equation? And then we're going to begin looking at how do you graph them. What is a linear equation and how do you graph them? So let's start with just defining what a linear equation is. And a linear equation is an equation whose graph is a line. All right, what does that mean? What does that look like? Here's an example of a linear equation. X plus 2y is equal to 3. Notice we have two different variables. We have an x variable and a y variable. That's one way to spot a linear equation. Why or how does it produce a line? Okay, well, let's take again a look at the equation x plus 2y is equal to 3. Here is the line of the graph of the equation x plus 2y is equal to 3. What happens is every value you give for x, there has to be a unique value for y that makes this algebraic statement true. Okay, so for example, let's just make a little table here. Okay, so for x and y values. So let's say that I say x is 0. If x is 0, substitute x with 0, then 2y is equal to 3 and y is equal to 3 halves. Y has to equal 3 halves to make this a true statement. So if x is 0 and y is 3 halves, then you get 3 is equal to 3. Okay, substitute x with 0 and then y with 3 halves. Okay, and 2 times 3 halves is 3, and 3 plus 0 is 3. That gives you a true statement. Okay, so the ordered pair, I'll write it over here, the ordered pair 0, 3 halves is a solution to this linear equation. Okay, let's say that x is 1. What does y have to be in order for, if x is 1, what does y have to be in order to give me a true statement here? So I substitute x with 1 and have 1 plus 2y is equal to 3. Okay, subtract 1 on each side, and so 2y is equal to 2. Divide by 2, and y is equal to 1. Okay, so if I put x in, 1 in for x and 1 in for y, I get 1 plus 2, which is 3. 3 equals 3. That gives me a true statement. Okay, let's say what if x is negative 1? All right, and we can you know, I'm starting with x's. We could go with y's. We could start with a y value and see what x would have to be to give me a true statement. But let's say what if x is negative 1? Okay, well, substitute x with negative 1. All right, and then we get 2y is equal to 4 divided by 2, and y is equal to 2. Okay, so another ordered pair that is a solution for the linear equation x plus 2y is equal to 3. Is 1 and 1 and negative 1 and 2. These three ordered pairs are solutions to this equation. Okay. Now what this means is, so all these, you know, all these ordered pairs will be found on this line. Okay, so the line of the graph is all the ordered pairs that are solutions to this equation. So for example, 0 and 3 halves. If I go over 0 and up 3.5, or which, you know, 1.5, which is 3 halves, I'm on the line. If I go 1 over and 1 up, I'm on the line. If I go 1 to the left and 2 up, I'm on the line. So all the x and y values, all the ordered pairs that are a solution for this equation are represented here on this graph. And later we'll see how that can be used with real-world applications. Okay, so that's what a linear equation is. You've got two different variables, and the equation, when you plug in values that are solutions to the equation, they produce a line. Okay, whereas if I had something like y is equal to x squared, okay, if I did the same thing, if I assigned a value for x, I would get a certain value for y, but if I graphed the values, the ordered pairs for this equation, I would not get a line, I would get a parabola. Okay. So the the solutions to a linear equation, when graphed, produce a line. Okay. Now, what you saw here, let's go back here, x plus 2y equals 3. That's an equation, that's a linear equation in what we call standard form. Okay, the standard form is quoted as ax plus by equal to c, where a is a coefficient, like and b is a coefficient. So for this equation here, 3 would be a and 1 would be b. Okay, and c is a constant, it's a number. Okay, so that's the standard form of equation. If we solved for y and isolated y by itself, so if I took this equation, y is equal to or y plus 3x is equal to 2, and I got y by itself by subtracting 3x on each side, that would be y is equal to negative 3x minus 2. So this is the same equation, but it's in a different form. It's called the slope-intercept form, and we'll look at that more closely later on. What I want to point out is these linear equations are functions. Remember, we've learned about a function that has a domain and range. For every input, okay, for every input, there is a specific output. Okay, so a linear equation is also a function. It has a domain and a range. Okay, so that's a little bit about linear equations, and then the next video we'll look at graphing them.